Assalamu alaikum to all the students. This is the first online lecture from a side. It is for all the students, 12th class students, especially for the students of Nisa Pampur and Amos Avantipura. In this first very lecture, we will discuss an important unit from the organic chemistry. The title of the unit is Organic Compounds Containing Functional Group Nitrogen. Here, in this very unit, we have to discuss four sub-important topics. The first is amines, the second is cyanides, the third is isocyanides, and the fourth, that is diazonin salts. As usual, we will start with the first subtopic, that is amines. We have to discuss the first subtopic, that is amines. Now the question arises, what is meant by amines? When you have to define amine, you have to simply remember these are the alkyl or aryl derivatives of ammonia. This is the definition of amines. How you can define the amines? You have to remember these are the alkyl and aryl derivatives of ammonia. It means that if you have to prepare amines, if you want to get the amines, you can derive them from the ammonia. This is the starting material. Let us say, for example, we have the ammonia. This is NH3. You can bring the replacement. In the replacement, you have to replace hydrogen and you can bring OR group. You can bring the OR group, and what you will get? You will get OR NH2. You can get OR NH2. It means that this is the amine. It is the class of organic compound. It is the class of organic compound. It has been obtained, it has been derived from ammonia by replacing hydrogen by the OR group. This OR group can be either alkyl, it can be aliphatic, or it can be aromatic. It can be either alkyl or it can be aryl. Hence, the definition is alkyl or aryl derivatives of ammonia. Alkyl or aryl derivatives of ammonia. The starting material is ammonia. You have to bring the replacement, in which you have to replace hydrogen by the OR, and the OR can be either alkyl or the aryl. It can be aromatic, and you get the OR NH2. You get the OR NH2. Now here you have to remember that you can replace either one hydrogen, you can replace two hydrogens, or you can replace all the three hydrogen atoms from the ammonia. For example, we will try to derive these derivatives. Let us derive. If you have the ammonia, if you replace the first hydrogen by the OR, if you replace first hydrogen by the OR, what you will get? You will have OR NH2. It is OR NH2, and that amine, which is obtained by replacing one hydrogen by the OR, it is known as primary amine, or you can say it is 1 degree amine. You can say it is 1 degree amine. So when you replace the one hydrogen from the ammonia by the OR, now you know the OR is either aliphatic or aromatic, you will have the primary amine. Now, if I will tell you what is the functional group of primary amine, functional group of primary amine, it is this NH2, and this NH2, it is known as amino. Well, the functional group of primary amine, it is known as amino. Now, if you take the primary amine, and replace the hydrogen by another R, what you will have? You will have R2NH. When you replace another hydrogen by another R, you will have another amine, and this amine is known as secondary amine. It is known as secondary amine, or you can say it is the 2-degree amine. You can call it the 2-degree amine. And what is the functional group of this secondary amine? It will be NH, because these are general groups. So you can say NH is the functional group of secondary amine, and this functional group is known as imino. The secondary function of this amino group is known as imino. Now, if you replace the third hydrogen atom, we will start from the secondary amine. We have another hydrogen here. If you replace this hydrogen by another OR group, you will have another class of amines. That class will be OR3N. This type of amine, it is known as tertiary amine. It is known as tertiary amine, or you can call it 3-degree amine. And if I will tell you what is the functional group, it is simply N, and it is known as tertiary nitrogen. This functional group is known as tertiary nitrogen. Well, how you can define the amines? Dear students, you can define the amines. These are the derivatives of ammonia. You have to replace the hydrogen from ammonia by the or. It can be either aliphatic or it can be aromatic. And from this here, it is clear that amines are of 3 types. Primary amines, which are obtained by replacing one hydrogen by one or. Secondary amines, these are obtained by replacing 2 hydrogens by the 2 or groups. And we have another category, that is tertiary amines, 3-degree amines. When all the 3 hydrogens are replaced by 3 or groups, at that time it is known as tertiary nitrogen. Now we will discuss this is the first classification as far as the amine is considered, that is primary amines, secondary amines, and tertiary amines. Now the second classification we will discuss as far as the amines are considered. We will write down the heading, that is classification of amines. Classification of amines. The first very classification we have discussed here, that is on the basis of number of hydrogen replacements. If you replace one hydrogen by one OR group, at that time it is known as primary or 1-degree amine. Well, if I will ask you how you can define primary amine, you can say it is the amine, it is the class of amines which are obtained by replacing one hydrogen from ammonia by one alkyl or aryl group. One alkyl or one aryl group. What is the general representation? The general representation will be OR NH2. And what is the name of the functional group? You should remember it. It is amino. The second type, it is the first type. The second type, that is secondary amine. You have the secondary, or you can say 2-degree amine. In the same way, you can define These are obtained by replacing. Remember here, instead of one, you have to remember two hydrogens. Definition is same. The only difference is that here you have to mention one hydrogen, here you have to mention two hydrogens. But when you replace two hydrogens by two alkyl groups, you get the secondary amine. What will be the general representation? It will be R2, and we have just one hydrogen because two hydrogen atoms have been replaced by two R groups. Here you have to remember what is the name of this functional group. It is imino. We have discussed it. The name of the functional group, it is imino. And the third type you have to remember, that is tertiary amines. Tertiary amines. Here you can call them 3-degree amines. 3-degree amines. How you can define these? These are the amines which are obtained by replacing. You have to remember here 3 hydrogens. In the primary you have to remember 1 hydrogen. In the secondary amine you have to remember 2 hydrogens. And in the tertiary amine you have to mention that these are the amines which are obtained by replacing all the 3 hydrogen atoms from ammonia. In the ammonia you have to replace all the 3 hydrogens, and the general representation will be R3N. Here we have no hydrogen because all they have been replaced by these R groups. And what is the name of this functional group here? It is tertiary nitrogen. Dear students, it is the first classification of amines on the basis of number of replacements of hydrogen. If you replace one, it is primary amine. If you replace 2 hydrogens, it is secondary amine. And if you replace all the 3 hydrogens, at that time, this type is known as tertiary amines. This is the first classification of amine. Now we will discuss the second very classification of amines. Classification of amines on the basis of nature of or groups. This is the second classification of amines. We have to discuss classification on the basis of nature of or groups. That is whether they are aliphatic, whether the or groups are aliphatic or aromatic. Well, you have to remember the second classification of amines. This classification is on the basis of nature of or groups, whether they are aliphatic or they are aromatic. On this basis, we have 2 classes. The first class is aliphatic amines. The first class of this category is aliphatic amines. Now, it is clear from the name, these are the amines in which nitrogen atom is attached. Nitrogen atom is attached to 1, 2, or 3 alkyl groups. 3 alkyl groups. In this type, the R groups are aliphatic. They can be methyl, ethyl, propyl, all are aliphatic in nature, or are alkyl groups. And it can be 1. It means that it will be the primary. The number will be 2. It can be the secondary. The number can be 3. It can be 3 degree. For primary, secondary, and tertiary, we can say aliphatic amines. These are the amines in which nitrogen atom is attached to 1, 2, or 3 alkyl groups. They can be either 1 degree. They can be either 1 degree. They can be either 1 degree meaning primary, 2 degree secondary, or they can be 3 degree. For example, let us talk about the 1 degree. We will take the example CH3NH2. It is clear that here the R group is alkyl, methyl. It will be the and it is attached to amino group, it will be the primary. Only one hydrogen has been replaced. I can say it is 1 degree. Similarly, now we have secondary. The example is CH3. You will have NHCH3. Two hydrogen atoms have been replaced by two alkyl groups. It will be the secondary amine. Now we have the 3 degree. Here what you have to mention, the nitrogen atom is attached to 3 alkyl groups. This will be the 3 degree. Well, this is the second classification we are discussing. The second classification of amines. The title of the heading is Classification of Amines on the basis of nature of all groups, whether they are aliphatic or aromatic. Here we have discussed the first type, aliphatic amines. How you can define the aliphatic amines? There, so you have remember, in this type, nitrogen atom is attached to 1, 2, or 3 alkyl groups. This type can be either 1 degree, 2 degree, and 3 degree. These are the examples. Now the second type, you have to remember here, aromatic amines. You have to remember the second type. I can mention the B type, aromatic amines. This is the second type, that is aromatic amines. Now it is clear from the name how you can define the aromatic amines. These are the amines in which the nitrogen atom is attached to aromatic group. For example, first I will take 2 examples to understand. Let us say you have benzene ring, aromatic aryl group. We will attach amino group to this. It will be the aromatic amine. Now we will take the case of benzene ring, and I will keep the side chain to this. It is toluene. Actually it is toluene. If you replace this H by NH2, if you look on these 2 compounds, you will say, sir, it is aromatic amine because benzene ring is there. It is also aromatic amine because the benzene ring is there. Now it is clear that in this type of aromatic amine, amino group is directly attached to benzene ring. It forms one class, and here the amino group is attached to side chain. With this aromatic amines, these are of 2 types. The first one is this one. When amino group is directly attached to benzene ring, this type is known as aryl amines. Aryl amines, or you people know the second name, it is nuclear substituted amines. It means that as far as the aromatic amines are considered, these are of 2 types. The first type is when the amino group is directly attached to the phenyl group of benzene ring. This type is known as aryl amine, or we have the nuclear substituted amines. Now the second type is when the amino group is attached to side chain of the benzene ring. Amino group is not directly attached to benzene ring. It is attached to the side chain of the benzene ring. At that time it is known as R. This is aromatic part. You know the R. This is alkyl. R alkyl amine. The second type is known as R aromatic alkyl, R alkyl amine, or it is known as side chain. This type is known as side chain substituted amines. Substituted amines. Dear students, here you have to remember aromatic amines when the amino group is attached to the aromatic group, but this type is of following 2 types. When the amino group is directly attached to benzene, what is the name? Aryl amines or nuclear substituted amines. What is the second type? When the amino group, when the functional group is attached to the side chain of the benzene ring, at that time it is known as alkyl amines, or we have the side chain substituted amines. First we will define this type, then this type with examples. To clear it, let us say you have to remember the first type, that is aryl amines. It is also known as nuclear nuclear substituted amines. How you will define this type? So these are the amines, aromatic amines, in which amino group, that is the functional group, is directly attached to the benzene ring, directly attached to the benzene ring, directly attached to the benzene ring. So when the amino group is directly attached to the benzene ring, the name is aryl amine or nuclear substituted amines. If you take examples of this type, you can say, sir, amino group is directly attached to the benzene ring. This is the example. You can take another example. You will have benzene ring, you will have NH, but here in this type, you will replace another hydrogen atom by the benzene ring. You know the classification. When it is attached to only one OR group benzene ring, it is 1 degree, primary aromatic amine, primary aryl amine. Here NH group is attached to the 2 benzene rings, it is 2 degree amine. And when it is attached to 3 benzene rings, when it is attached to 3 benzene rings, at that time it is known as 3 degree amine. You can have, remember, you can say, sir, this type is of 3 types. Further, it is of 3 types. It is 1 degree, it is 2 degree, it is 3 degree. This one is primary, this one is secondary, this one is tertiary. But in all the 3 types, you will find one common thing. What is that thing? Nitrogen atom is directly attached to benzene ring. When nitrogen atom is directly attached to benzene ring, at that time, it is known as aryl amines, or you can say nuclear substituted amines. It is of following 3 types. It can be primary, it can be secondary, it can be tertiary. Now we will take the second type, second subtype, when the nitrogen atom is attached to the side chain of the benzene ring. What will be the name? You know the name now. It is R alkyl amines, or alkyl amines, or you can say side chain substituted amines. How you can define this type? Simple definition. In this type, the nitrogen atom is attached to amino group is attached to the side chain of the benzene ring. Side chain of the benzene ring. It can be either, as usual, it can be either 1 degree, it means primary, it can be 2 degree, or it can be 3 degree. You have to remember, like the first type, this type can be also 3 types, primary, secondary, and tertiary. For example, let's take the examples now. Primary, you will have 1 benzene ring, this is the side chain, and here you have the amino group. It will be the primary. You will find the functional group is NH2 amino, it will be the primary one. Now what will be the secondary? You will have the benzene ring, you will have NH, but another hydrogen has been replaced by another benzene ring. It will be the 2 degree. Now what will be the 3 degree? So in the 3 degree, hydrogen will be attached here. You have to mention, there will be a little bit change. In the secondary type, what will be the case? You will have CH2. You will have the CH2 and you will have NH. This will be the case. Another hydrogen will be replaced by the benzene ring. This will be the case. And this will be the second type. And we have the third type. You will have the benzene ring, you will have the CH2, you will have N. Here you will have benzene rings. Benzene ring can be represented by pH, that is phenyl. Remember this point, radical of benzene, it is phenyl. It will be the third 3-degree type, tertiary type. Primary, we have the secondary, and we have the tertiary. It means that this type are alkyl amine. This is the R, this is the alkyl, this is the amine. And what is the second name? Side chain substituted amines. Amines. In this type, the amino group is attached to the side chain of the benzene ring. This is the second classification of the amines. Now you have to remember the third simple classification of amines. Third simple classification of amines, that is simple and mixed amines. Simple and mixed amines. Simple and mixed amines. This classification is for secondary and tertiary amines, not for primary. If this classification here, it is for secondary and tertiary amines. What the simple amines means? Simple, or you can say symmetric amines. You can say symmetric amines. Simple amine means when the nitrogen atom, secondary, it is secondary, but both the alkyl groups are similar. When both the alkyl groups are similar, at that time it is known as simple secondary amine, a simple amine. When both the R groups are similar, they are like, for example, you will have NH. I will take here, it is the benzene ring. Here it is also the benzene ring. I will take another example. You have ethyl, NH. You will have also another ethyl group. When both the R groups are similar, at that time it is known as simple, or it is the symmetric amine. We have the second type, mixed amine. It is counterpart, it is opposite type, mixed or unsymmetric amine. Unsymmetric amine. How you can define this now, this type? Simple. When the R groups are different. When the R groups are different, when the R groups are different, when the R groups are different, at that time amines are known as mixed amines. It can be either secondary or it can be either tertiary. Let us take examples. Let us take the examples of mixed. For example, you will have CH3, CH2, NH, CH3. Here you will find that one group is alkyl, another one is ethyl, second is methyl. They are different. It will be the mixed. I will take this example also. You will have C6H5, NH, you will have CH3. One is phenyl, second is methyl. They are different. This is secondary mixed type. It is also secondary mixed amine. I will take the exact secondary mixed. It is secondary mixed. You can also take examples of 3-degree amines. 3-degree, but they are mixed. For example, you will have CH3, CH2, CH2, NH. You will have CH3. You will have CH2, CH3. Here it is clear that one is propyl, another is ethyl, another is methyl. Whether it is simple or mixed, it is mixed, or you can say unsymmetric amine. It is 3-degree, but you have to remember whether it is simple or mixed, it is mixed 3-degree amine. This was the first topic of this very unit, that is organic compounds contain the functional group nitrogen, and the first topic we have discussed, that is the classification of amines. Inshallah, in next lecture we will discuss the nomenclature of amines, inshallah.